In this video, we will solve quadratic equation using quadratic formula. Quadratic formula is the formula that can be used to find the solution to a quadratic equation. To be able to use the quadratic formula, a quadratic equation must be of the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a must not be equal to 0. When we are solving a quadratic equation, it is always a good idea to start off by checking if you can factor or graph that quadratic equation. Now, sometimes it is difficult to factor or graph a quadratic equation. If that happens, you can use the quadratic formula in order to find the solution. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now that we know what a quadratic formula is, let's take an example. Let's look at x squared plus 5x plus 8 equals 0. The first thing you need to consider before using the quadratic formula is to verify if the equation is equal to 0. If it is not equal to 0, you need to manipulate your equation and move everything to one side of your equation in order to make it equal to 0. Now, if we look at our equation, it is already equal to 0, so we can use the quadratic formula. The next step is to identify our a, b, and c in our quadratic formula. These are the numbers that we are plugging into our formula to solve. First, we find a. A is the coefficient of x squared. In this case, we have an invisible 1, so our a is equal to positive 1. B is the coefficient of x. In this case, we have 5. And then c is the constant, and which is equal to 8. Once you identified a, b, and c, plug them into the formula. So we'll have x equals negative 5 plus or minus the square root of 5 to the second power minus 4 times 1 times 8 all over 2 times 1. Following the order of operations, we will simplify first what's under the square root. So we'll have x equals negative 5 plus or minus 5 squared is equal to 25 minus 4 times 1 times 8 is equal to 32. Then all over 2. Simplifying further, we'll have x equals negative 5 plus or minus the square root of negative 7 all over 2. Now, the square root of negative 7 creates a problem because we can't take the square root of a negative number. Also, this value is what we call the discriminant. If the discriminant is less than 0, then we can say that our quadratic equation has no real solutions. In the next few days, we'll learn about complex solutions. But for the meantime, let's take the plus and minus and split them up into two separate expressions, because as we go further, we'll have to write about complex solutions. So taking the plus, we'll have x equals negative 5 plus the square root of negative 7 over 2. And then taking the minus sign, we got x equals negative 5 minus the square root of negative 7 all over 2. So again, for the time being, we will leave our answers in these forms until we discuss about complex solutions. Let's have another example. Let's take 8x squared plus 6x equals negative 5. So again, the first step that you want to check if your quadratic equation is equal to 0. In this case, as you can see, is not equal to 0. So we have to manipulate our quadratic equation and make it equal to 0 by adding 5 on both sides. Adding 5 on both sides, we'll have our new quadratic equation 8x squared plus 6x plus 5 equals 0. Now we can use the quadratic formula to solve this quadratic equation. So now let's assign our a, b, and c from our quadratic equation. So again, a is the coefficient of x squared. So in this case, a is going to be equal to 8, b is equal to 6, and c is equal to 5. Plugging into the equation or to the formula, we got x equals -6 plus or minus the square root of 6 squared minus 4 times 8 times 5 all over 2 times 8. Again, following the order of operations, we will simplify first what's under the square root. We'll have x equals -6 plus or minus the square root of 36 minus 160 all over 16. And simplifying it further, x is equal to -6 plus or minus the square root of -124 all over 16. And then again here, the square root of -124 creates a problem because our discriminant is less than 0. So again, we know that if it is less than 0, our quadratic equation has no real solutions. And then again, for the meantime, let's take the plus and minus and then split them up into two separate expressions, because like I said, as we go further, we'll have to write about complex solutions. So let's split this into two expressions. So we got x equals -6 plus the square root of -124 all over 16, and then taking the minus sign, x equals -6 minus the square root of -124 all over 16. Again, for the time being, we will leave our answers in these forms until we discuss about complex solutions.